I will start here with API design. API design. Okay. So API design. So the very first API design would be post. And let's say we can create yeah, so we can have it any name. So for example, we can have it like post. Instead of create, we can have shorten. Okay. This will be my post API, and then it can have input. Input could be my JSON of long URL. All right. And that long URL can be anything which is HTTPS, and then it could be something like this .com. And this is my input. And what is the output which I am expecting here? Output is, I'm expecting again a JSON with short URL. And this short URL will be HTTPS. And it will be, let's say, short.ly. This is my service ABC. Okay, 1, 2, 3. So this is my post API. Okay, which is very simple and straightforward. And then I will have my get API. In get API, what I can do, yeah. So in get API, in get API, so in get API, what I have to pass, as my query param short URL. All right, ID. So this what I have to pass. So input will be short URL ID in the URL param, and then output would be long URL. Okay, and in the long URL, I'll get this original URL. Okay, so this is my, on a very high level, this API design looks like. Okay, I mean, these are the main important APIs which are connected to the shortening service. There are many more, which depends on the interviewer. You can just talk about like if how, for example, for how what should be the tentative TTL for a short URL. Should it be deleted after some days, or should we have a delete API to delete short URL or something like that, right? So this is API design. Now, when it comes to database design, um, so when it comes to API design, you know what is this? When it comes to database design, we have one table which is called URL table. So let me write this database design here, another column. Yeah, database design. Yeah, so database design is this. Make it be. Yeah. So URL table, URL table, and URL table will have columns, which will be, for example, ID would be my primary key. Long URL would be then created at, then expiry date, then user ID, then click count, All these fields are very, very important. Yeah. And then we can have user table. Um, I can on a very high level talk about the data type. So ID can be string. Long URL can again be string. Created at would be a timestamp. Timestamp, expiry date, user ID again string. Click count would be an integer. All right. Uh, User table will have details about user. Sometimes we need these things like user related information, so that let's say we do not want our service to be bombarded by some bots, right? So for example, we can limit a particular uh, request number of requests, so we can have throttling into the system, so that this we make sure that the service is not down, the resources are not used in a bad way, because there are the hackers who are sitting in and they are hacking the service, like you're bombarding the service by some robots. So throttling, API throttling and all those things, they can be in that case you need user table to store the user information, mainly maintaining the sessions and all that. So over here you can have user ID, then you have email, then you have password hash, or it could be something else, like just on a very high level I'm telling you, because this password can be maintained on a managed identity level. You can also have user analytics table, URL analytics table, analytics table. So this URL analytics table is also very important here, as I said it now, that if you want to trace that, okay, from which geography my application is going to be used a lot. So this table can give you a lot of monitoring or information, which can give you an idea like where you have to scale, uh, how much throttling you have to decide. Do we have any hackers sitting around? So ID, timestamp, we can trace the IP address, right? IP, IP address, user agent, referrer, geolocation. All right. So these are all important. This is user analytic table. It is very important. Again, it depends on your interviewer to see whether it is important or not. Yeah. Um, so yeah, these are on a very, very high level. Some of the important table. There can be more. It depends on your interviewer. But yeah. And similar to these tables, you can add here more APIs also. For example, you can add here API to get the analytics. Of course, those APIs are not going to be used by your front end. You're not providing those APIs to the external user, but instead you are providing those APIs to your monitoring jobs, right? So, for example, it can be analytics, and then it can just return something which is very, very important, right? Important information from this analytics table. So return important information, okay, whichever you need. uh, so now let's talk about some of the important thing which is connected to advanced functionalities. Again, depend on your interviewer, like whether he's interested or not, but I just want to highlight, as I already highlighted some of the tables, is that there are some advanced functionalities that we can provide to the user. Is that expiry handling? Okay, so automatically delete, for example, or deactivate expired URL using a background job. So let's say a background job, you can write a background job in Java, a scheduler, let's say sprint scheduler, and scale it to whatever level you want, depends on your needs. And then it will automatically delete and deactivate expired URLs. Okay, it automatically delete expired short URLs. So every time when you generate a short URL, let's say you provide a user something wherein you also give user a flexibility to add, like, after how many days this API, this short URL should be deactivated or expired. Then we can have like throttling, which is very important concept, okay, to prevent abuse. Those who do not know what is throttling is like rate limit API, meaning um, some rate limit API. So for example, let's say I'm on this laptop, I'm using let's say if over here this is also a short URL. So let's say I write a code and just hit this service 1 trillion times. Okay, so should I be allowed to hit this service to generate the short URL 1 trillion times from the same machine, from the same IP? No, it should not. If something like this happening, it's not the real human user. Instead, it's a bot or some program or some abuse which is happening to the system. So throttling is something which we can use. You can also have can talk about like QR code generation. So QR code generation is generate QR code for short browser for easy sharing. So I think you know this feature very well. So this is related to advanced functionalities of the service. Okay. So now we talk about which cloud service we should use, right? For example, database, API gateway, or for example, c- cache, uh, or anything like which is important. Uh, so yeah, let's talk about that, which is the technology part, very important. So I'll make another heading here like this. So technology, yeah, technologies instead. All right. So when it comes to database. So mm, all right. Um, so you can use here relational databases. For example, uh, for storing the user details, relational databases is best. For example, if you want to have very high read write throughput, you can go for DynamoDB, Amazon DynamoDB, which is a very good fit to the database. So, for example, URL mappings, analytics. So, I would say for user details, we can have any RDS instance like MySQL or Postgres, SQL. Um, for analytics, URL mapping, we can, because it's very high read and write throughput required here. So, because it is high read and write throughput, high read write needed. So, we can use here AWS or Amazon DynamoDB. No, uh, For cache, we can use, okay, for cache, we can use, it was one. For cache, we can use um, AWS Elastic Cache. So AWS Elastic Cache, or for example, Azure Cache, whichever cloud provider you want to use. So AWS Elastic Cache. So API gateway, still like you can use AWS API gateway. So it easily integrates with your uh, with your Lambda functions, uh, or you can have your API gateway configured, which can handle all the requests, and API gateway can handle this flawlessly, right? So uh, AWS API gateway. So all these things are very highly scalable. You do not need to worry about. Uh, when it comes to object storage, so for example, we talked about QR codes and all that. So this Amazon S3 can be used. S3 for object storage like QR codes. So so QR codes, metadata, logs, all those things, they can be stored in Amazon S3. For monitoring and logging, um, is we can use AWS CloudWatch for monitoring and logging. So it automatically give you all the analytics. Uh, so yeah, I mean, these are on a very high level some cloud services that you can use for on the technology side. When it comes to making those services in real, so I'll again take this up. Yeah. So what I was trying to explain you, like the front end can be created in React, Angular. You can deploy it to Kubernetes cluster either on cloud or on your on-prem cluster, wherever you want. It can be Azure, it can be your AWS Word, anywhere. You can scale your application, depends on your need for your scalability. The front end application, then it can talk to an API gateway, which is again an AWS behind an AWS load balancer, which is also scalable. There is no problem. And then your API gateway can talk to shortening service. Okay. So now let me quickly uh, design very high level diagram. All right. For this service, so that it looks like high level block diagram. Uh, so when I say high level block diagram, meaning I would just cover up here uh, high level diagram and how they connect to each component. So this is how exactly we are going to see now. So I have my user, which is front end. So I'll design my front end here. This is my front end. All right. Okay. So this front end is uh, provides the user interface. Okay, where user puts something and then sends an API request to the API gateway. Okay, so this is my API gateway. API gateway. Okay, and over here it will actually okay. So Now what will happen? API gateway routes user requests to the appropriate backend service. Okay, so this is my backend service, so which is shortening service. Okay, this is my shortening service, and this is a scalable service. And we have multiple replica for this particular service. All right, and then this service over here, it connects to redirection. Okay, so this will be a redirection service, because so this shortening service generates a unique short URLs and maps them to the long URL. Okay, um, and then redirect service, what it will do, it handles redirection when a short URL is accessed. So this, okay, let's detach it from here. This redirection service is also sitting somewhere here, and the responsibility of redirection service is and this is also uh, scale, because the responsibility of this service is to also handle a lot of requests. And yes, so this will talk to this. So whenever there is a requirement that, hey, you need to return a long URL for my short URL, so this redaction service will take that short URL and um, r- return you the long URL and redirect user to the long URL. So that's how it works. Uh, Similarly, this is also used by shortening service whenever there is a need. And each of these services, they have their own databases sitting. Um, MySQL, which will be, so let me make a database here, not this. Okay, so I go here, more shape. Okay, yeah. So this is the database which it maintains. And yeah, so this is how it works, right? API gateway, it talks to both of these services, and then redirect service, shortening service talk to database. It could be MySQL, and then redirection service. mm, Always it can talk to Redis cluster. So I can make here one cache, which is Redis. Okay. Uh, so now I explain you the overall design here. And then we can have here one more service, which is monitoring service, right? So this, okay, so 1 second. I need to change the shape. Yeah. So we have here monitoring service, and monitoring service is writing to its own database, which will be analytical database. Analytic database, and this is connected to this. And let's say there is some Kafka sitting in between. So every time when those applications work, so they talk to some messaging queue. All right. So they talk to some messaging queue. So all these services, for example, this connect to this. Similarly, this also connect to this. So all these services, they actually, yeah. So all these services, they are sending messages to here, which is Kafka JMS queue, and this Kafka JMS queue is sending the message to monitoring queue over here, and monitoring service is doing using uh, some artificial models. So let's say there is a service, there is a model which is here, machine learning, okay, models. And these machine learning models, uh, they are reading the data from, okay, so these machine learning models are sitting here, and what they are doing, they are reading data from this analytical database, and they are making their output to another front end monitoring UI, okay, or analytical UI, analytics UI. Okay, so that's on a very, very high level, the whole system design problems looks like. So we are covering here the part which is related to throttling, abuse. We are covering here the part which is related to scalability. We are covering here the part which is related to redirection. Redis is also there to process requests faster. Clouds providers are used to process those requests scalable way, because we are using AWS service here. Then this is the database which we are using. Type of database, I already explained you what database type you can use. Kafka is used in real time. This is not needed, so I'll remove this. Okay, where is this? Remove. Okay, delete. Monitoring service is responsible to take all those data from these Kafka topics which are generated in real time. Yeah, so as I said, you can have the service to delete. I mean, there can be a backend job here. uh, yeah, so it can sit here, uh, backend job, okay, which can read data from this, and then it can actually perform deactivation for expired URLs. So this can do in backend, and that's pretty much all. I hope you like my URL shortener system design database solution. I tried to cover everything. Uh, I tried to cover the core important concept. This is base 62 if you not aware of that. There are some important topics which are always very important to understand. I have created a separate series for that, and the important topics are: what is throttling, what is throughput, what is latency, what is scalability, what is fault tolerance. These are very, very important concepts. You must understand those concepts when you are designing a system, when you are going to prepare for a system design problem. I see you in another video. Thank you very much.